Before we move on today to a new lesson, let's go back to our lesson from last week. We were talking about the model of direct variation, y is equal to kx. So that's where we'll pick up. When we're looking at this model, we know that the variable k represents a constant. It's a constant of variation. It tells us by what value, by what amount x and y vary. We also found out that this is also equal to or represents our slope. So now that we know that, let's take the values that are given in this problem and we're going to replace them into the model. It tells us that 20 is equal to k times 5. One inverse operation will get us the value of k. K is equal to 4. So now that we have the constant of variation, we need to write the equation that relates these two. And this is where some of you had a little trouble on the homework. When I want to write the equation, I go back to the model, and all I do is replace the given value that we found for k into the model. That's the equation that relates the variables x and y. To the graph, we'll start at our origin. We found out that when we graph a model of direct variation, it passes through the origin. Since the constant of variation is also my slope, and slope is rise over run, and it's a whole number, place that over 1. At this point, we'll count up 1, 2, 3, 4, and over 1, and we'll connect. Arrows at both ends, and you have a graph of the line. There was one more thing they wanted us to do. Now that we have this equation, they want us to evaluate or find the value of y when x is equal to 10. Substitute in the value for x, simplify, and now you know that when x is equal to 10, y is equal to 40. If we were able to extend this line further on my graph, we'd see that those 2 points are on the line. One more example just to be sure we have this, and if we don't, feel free to ask for more examples in class. X and y vary directly when x is 20 and y is 4. Step 1, let's replace those values into the model. One inverse operation, and we'll find the value of k. Now k is equal to 4/20ths, which can be simplified to 1/5. It was a proper fraction that simplifies to a proper fraction. In order to write the model or the equation that relates the two, we'll just take the k and replace it with that value 1/5, and there is my equation. They ask us to sketch the graph. Model of direct variation begins at the origin. My slope is 1/5, tells me to go up 1 and over 5, and there is my line. Sometimes they will ask us to evaluate, and if they do, I will then just input the value that's given for x, and I will simplify, and I'll find out that y is equal to 2. So when I input 10, my output is 2. The next topic in our discussion of graphing will be another type of quick graph called the slope-intercept form. Y is equal to mx plus b. I give you the equation in slope-intercept form. I ask you to identify these two key items, the slope and the y-intercept. When I want to graph this, now think back to the model of direct variation, it started at the origin. This graph is going to start at the y-intercept because we know how to graph a y-intercept. It's a point on the y-axis. Now that I have my first point, I need to use my slope, which is a -3/4, to find at least one more point. Count down 3, 1, 2, 3, and over 1, 2, 3, 4. All I need are 2 points in order to graph a line. Let's connect those points. Kind of missed a little bit there, but you got the hang of it, and there's my graph. Notice that this is going downhill, which is negative, and 3/4. is a negative 3/4. So the two match. So always be sure that you do check that. So what did I do? Here are the directions, or here's the you know, information that you need. When we're looking at quick graphs using slope-intercept form, we're looking at y is equal to mx plus b. Recall that m is your slope and b is your y-intercept. We'll start graphing by the y-intercept. That's a point that falls on the y-axis. From there, we will use the slope, rise over run, to find one or more points. We only need two, but sometimes you like to do more than one just to be sure you have the proper smooth flow of the line. Let's do an example or two. In my first problem, you're going to see that y is equal to mx plus b, and I'll give you the equation. I will ask you to identify your slope and identify your y-intercept. If it's a whole number, place it over 1. If it's positive, you know you'll go up and over to the right. Where should you start graphing? Well, step 1 says graph the y-intercept first. 1, 2, 3. Now I use my slope. Since slope is a ratio of rise over run, we'll count up 1, 2, 3, 4, and over 1. 2 points, all I need. Connect your points, arrows at both ends, and you have your graph. A second problem of the same type would be y is equal to mx plus b. I write that at the top in the beginning. Obviously, you must know it by now, but it lines up to tell me that my slope is 2 over 3 ratio, and my y-intercept here is a negative 4. Thinking back to example number 1, we start graphing at our y-intercept, counting down 1, 2, 3, negative 4. My slope is positive. I'm counting up 1, 2, and over 1, 2, 3. And there's my point. My second point and my y-intercept, and I have a graph. Slope is constant. I could have again gone up 2 and over 1, 2, 3. You would see that point right there. That's not necessary, but I do like to do it from time to time. Try the next one on your own and just do a rough sketch. If you happen to have graph paper, use it for precision. But right now, for the sake of just practice, we identify our slope and our y-intercept. We stop and we think about, well, how do I start graphing? From the y-intercept. My slope here is negative. It's telling me to go down 4 and over 3. So let's count down 1, 2, 3, 4 and over 1, 2, 3. And there's my 2 points. There's my connection. And there's my line. Negative slope, negative number. There'll be times when you're not given the equation in slope-intercept form. You might be given standard form. If I gave you this equation and I asked you to graph it using slope-intercept form quick graph, you would first need to rewrite it. And we've had lots of practice in this, where we isolate y in terms of x. And then we'll divide by 5 on all terms. And simplify. Y is equal to 2/5 x plus 3. It's in slope-intercept form. And now you can graph.